Good afternoon, everyone. Welcome to our Dynamic Talks 88 at Grid Dynamics. We are very glad that you have joined us. Today we are waiting for 2 lectures. I see that we have new connections every minute, so I think we will wait for maybe 1-2 minutes and we'll start. And I will moderate today's meetup. So maybe, Marika, we can say some words about our company while waiting for other participants.
Yes, of course. Hello, everyone. And till we're waiting, we will talk a little bit more about Grid Dynamics. The Grid Dynamics is a leading provider of technology consulting, engineering, and data science services, Fortune 500 corporation from financial, technological, and retail sector. Our company has been operating since 2006 and is headquartered in California and has development centers in United States, Eastern and Central Europe. So as of today, Grid Dynamics brings together more than 3,500 engineers in 14 different countries. As you can see, we have a large amount of different offices in different countries, and we continue to grow up steadily. So Grid Dynamics is a NASDAQ-listed public technological service company with core expertise in big data, data science, machine learning, and IE, scalable omnichannel services, DevOps, and cloud enablement. So also you can find more information on our site, griddynamics.com. And to understand who we are working with, you can see the list of our partner and clients in different spheres like tech, finance, retail, and others. So more information you can find also on our career side. And if you want, until we're waiting for people to join, you can go by this QR code to our site and search for some career opportunities if you want, or read more about our company. So thank you for joining.
Well, I guess while we're waiting, we can do my favorite kind of tech talk activity. So I encourage you, first things first, my name is Vladislav. You can call me Vlad. And today I'll be one of the speakers with...
I will introduce you later.
Okay, sure. But anyways, I guess, I encourage all of you to write maybe your location and your specializations. I don't know, UI, or maybe you're a project manager or a custom dev. So we know our audience. So guys, I encourage you to share that kind of information in the chat.
Yes, thank you, Vlad. And I will introduce you and the second speaker while we are waiting. So my name is Elvina Gain, and I will moderate today's meetup. I am going to introduce our speakers today. It will be 2 lectures from our UI developers at Grid Dynamics. The first will be Alexey Gaynulin with speech about how you work as a software engineer affects the environment. And the second will be from Vladislav, and it will be about Next.js, the evolution of React development. So, okay, we have some comments.
Yes, from all over the world, you know.
Yeah, I see Poland, Mexico, Armenia, Serbia, Ukraine. I think we can start. I invite the first speaker to take a virtual microphone and start his lecture. Alexey, are you ready?
Thank you. Thank you for this introduction. Let me share my screen. My name is Alexey Gaynulin. I am software engineer, let's put it this way. And the title of my presentation today is eco-engineering. And before I start, I would ask you to think about, is there any eco agenda in your work or in the IT industry? What do you think? No need to answer, to be honest. Just please hold your opinion, and it might be interesting to compare this current opinion with the opinion after the presentation. Just you can check this comparison. So the title of my presentation is Eco-engineering. In the summer of 2021, the report on global warming was released. There are the links for it, the report itself, and the United Nations Organization article about the report. In short, brief, unfortunately disappointing conclusions that can be drawn from this article. The climate is undergoing accelerated changes, and some of them are already irreversible. And the worst news is that even the most optimistic forecasts fall short of the goals of the Paris Climate Agreement. In short, the planet is warming faster than expected. So, unfortunately or fortunately, people have different views on this topic and the anthropogenic impact on the climate change. All of these views, roughly speaking, can be classified into three categories. One or another way, we need to do something, at least accept the fact of global changes. Disagree with the conclusions and in general with the whole climate agenda. Or there is also the point that I'm not interested in it and just don't want to dive into this topic. To my mind, all of these categories of views have the right to exist, and I don't consider it necessary to convince anyone of something. Relating, after all, to the first category, I allowed myself to reflect on this topic. And I asked myself, what can I do? Very short, all my thoughts were mutated to the plain, how does my activity affect this problem? And then, recalling that I'm a software engineer, I asked myself, is there any eco agenda in my work at all? In IT, eco-engineering is possible and can be practiced, or even should be practiced. Moreover, every experienced, truly mature developer strives to practice eco-development. Before I will justify this thesis, small disclaimer, I don't want to convince anyone of something. I'm just sharing my thoughts. It's a topic to discuss. Engineering, it's not a manual or guide for something. It's just a topic to discuss. Eco theme is quite controversial for many people, and calling for something is very ungrateful thing, I would say. And I don't have such a goal. I just want to share my conclusion that I made for myself, that responsible resource consumption is a sign of a mature developer. That is what eco-engineering is. So it is important to be a good manager, senior engineer, team lead engineer, architect, CEO, STO, never mind, whoever, without thinking about resources. Without considering resources, any project eventually becomes more expensive, more complex, inefficient, and in the end, less eco-friendly. Why we will talk about further. There are examples of an efficient usage of resources. For example, in human resources, it could be overstaffing, inefficient use of the team, mispositions for staff, team demotivation, or even over-motivation of a team. In organizational resources, it could be extra communications, unnecessary procedures, ineffective links, connections, and so on. In the technological aspect, there are examples of inefficient usage, the wrong inappropriate technology chosen, resource-intensive technology, and so on and so forth. And let's focus on technology aspect of inefficient usage of technologies. The result of inefficient resource usage always leads to lost control over the project, decrease in the quality of the final product, increase in the cost of project development, both in money and time, and many other problems. Careful resource usage is an indicator of maturity and responsibility of any experienced project manager, project owner, senior developer, even middle developer to my mind, architect, never mind, each of us, we should consider resources. And in fact, this, of course, is typical for any industry, not just IT engineering. In this regard, let me conclude that, let me make an assumption that if I don't think about resources, it's too early for me to recognize maturity in my trade. I would put it this way. Okay, so we need to think about resources to save money and time. But how does this correlate with the environment? Why is responsible resource management in IT green and eco? How does software engineering exactly influence resource management and consumption? To answer this question, let's ask ourselves, what does an experienced engineer usually use? What practices or principles does he or she use? To implement any software product, we have to follow basic engineering principles. For example, dry principles, keys, and so on. Dry it is don't repeat yourself. Keys it is keep it so simple, and so on. All these principles eventually lead to don't repeat extra code, don't provide extra entities, entropies, decreasing extra requests for getting data, and finally less code. Also, common best practices always lead to following of the common and best practices leads to sharing knowledge, information, tools, common usage of the same tools, implementation of such common tools, less creation of already existing tools, and so on. Such architectural patterns and principles such as solid, grasp, and many others also, they lead to organized structures, more appropriate structured code, more appropriate architecture of the application, reducing of extra entropies as well, variables, functions, classes, control over the development, decreasing extra requests for getting data, and less code as well. So in short, all of this practice in one or another way, they lead to decreasing of the entropy of resources. It means they lead to efficient usage of resources. And eventually, even well-known tool, engineering tool, and product that we use is based on these principles, on the basic principles of engineering. So any CDN technologies, for example, shared libraries, common architectural patterns, protocols, cloud infrastructure technologies, and many other technologies that are based on these principles. Principles that any experienced engineer should use in his work or her work. Okay, common and best practices, safe resources, but why is it eco-friendly? Violation of such principles, violations of such patterns, inappropriate choice of application architecture, and so on and so forth, they lead to increasing the amount of code. Violation of these practices always will lead to increasing the amount of code. Therefore, the final bundle size increasing, the code is stored somewhere, bytes, gigabytes, terabytes of data are stored somewhere for a long time, and I have not, of course, conduct any researches yet. I'm pretty sure that most of the code that is stored is used once or several times, and but it should be used for considerable time. So for their storage, for storage of our code, we need to maintain data centers with cooling, energy consumptions, and so on and so forth. So increasing violation of these principles, and which leads to increasing of the amount of code, it's not eco-friendly in short. What about extra network traffic? Violation of these principles also leads to extra network traffic. Additional unnecessary requests for data or for rendering data, but each byte transmitted over the network, downloaded over the network, increases power consumption. And also violation of these principles leads to unoptimized code, an increase in the load on the resources of any device, which leads to a device faster discharge. For example, any unoptimized code will give more load on CPU, and we have to additionally charge our devices, smartphones, computers, and so on and so forth. It is also not so eco-friendly. So let's take a look closely at each of them. Increasing the amount of code. There is so-called carbon factor. If you save and store 100 gigabytes of data during a year, the amount of electricity required to accomplish this would result in the emission of about 200 kilograms of CO2. At the same time, about 30%, approximately 30% of global data center servers are either underutilized or completely idle. 30% is quite a big amount, but this amount is even more because what consider underutilized or idle data. So what consider an underutilized or idle data? Yeah, let's imagine that we have, for example, 100 of Docker images and use them only once and constantly use only few of them. For example, we use only once these Docker images for testing or for such purposes. And such hundreds of Docker images that we used only once are not considered as underutilized in this statistic and counts in the above statistic in 70%. So we have a lot of code stored on our global data centers that are used once or several times. It's So it's a big problem, could be. Not populating such underutilized instances can be considered as the software engineer responsibility, to my mind. What about extra network traffic? According to different researchers, the energy cost of data transfer is from 3 to 7 kilowatts per hour per gigabyte. Every byte transferred over the network costs something. And at the same time, we transfer data over the network, the same data, a lot of time. Yeah, so we don't only load it every time we visit the same site, for example, we load pretty the same data. So of course it could be not so big that one, so we need to decrease the amount of handled bundles, because in the context of network traffic, could be a very big amount of data to be taken into consideration. So unoptimized code. Suppose, let's imagine that we work at large, very popular web application that millions of people visit every day, and our code is not optimized. And when visiting the application, there is an extra load on the CPU of a user, on their smartphones, and so on and so forth. And let's say all the millions of users of the application are forced to charge their smartphones 5 or 7% more often. As an example, I can mention one very popular taxi ordering application. In my case, I even don't try to use it when I have less than 15% of battery. So it could be a very interesting task to estimate how many electricity is wasted because of not optimized code. Okay, so what can we really influence? This is what the developer, the engineer, not only so managers and all the people who work together in the same product, what can they really influence? So we are responsible for reducing the data storage that is almost never used. Such data on servers is the vast majority. We can reduce data traffic, and we don't overload hardware, save a device charge, or any device that you use their application. These all basic routine everyday examples which everyone faces and which software engineers can directly influence. To high extent, engineering, let's put it this way, okay, engineering directly influence these blue, red, yellow, and green areas. So as you can see here, it is a ratio. You can see this ratio in global electricity demand. It is even now it's quite big. For 2015, it is quite a big part of global electricity demand. The blue one is network traffic. The green one is data centers, storage in data centers. But as you can see, as expected in 2030, this amount of this ratio in global electricity demand that engineers can directly influence is growing. So it's quite significant part of global electricity demand, and that is the part that we can directly influence in our routine work. So what practical tips could be provided? At least don't populate extra builds. For example, for dev instances, for test environments, there is no sense to provide extra Docker images or any other images. You can rewrite them by uploading images with the same name, which replace the previous image instance. So it's quite easy to do. Reduce network requests. I can mention, for example, GraphQL technology, which is very powerful in network management, data over the network management. Yeah, we can use GraphQL. Of course, we can use REST, but GraphQL is more powerful. It helps us to reduce the amount of data that we need to request and to get from the server and so on and so forth. Reduce build or bundle size, reduce code size. For JavaScript and TypeScript and so on, so we can use Webpack, Rollup. Of course, there are a lot of builders and compilators for any programming languages and for many programming languages, and we can use it for zipping of our code. Inspect libraries you can use to cache them. Apply CDN for content caching and distribution for common libraries and packages. It means that there is no sense to get data from another part of the world. We can get the data thanks to CDN from the nearest endpoint and use the data and save resources. We can provide lazy loading not only for assets, images, but also for some heavy components. Let's imagine that, for example, we have a web application, or we have a I don't know, web page. At the same time, we have an infinitive scrolling on this page, and we try to render 100 items on this page at the same time, and each item has very, for example, heavy image to be loaded. So there is no need to load all the 100 images, heavy images. We can load only, for example, client will see only 10 of user will see only 10 items within his viewport, and we can load REST components in lazy loading, and we don't need to load all these components. We can load as much components as within this viewport of a user. I have more detailed information at media.com, but if you want, you can get acquainted with it. But let's go on. How to lazy load of heavy components. There is an example for React. We can optimize our code not to provide extra load for CPU, at least for CPU, to avoid over discharging. It is everything about algorithms, so-called big O notation complexity. Of course, sometimes it could be this complexity, this priority could be switched to adjusted to readability. We don't need to use all the everywhere the best practice of algorithms, so on and so forth. But yes, we should consider algorithms, the complexity, space complexity, time complexity of the algorithms. It is very important to prevent extra load for CPU. And we can use cloud technologies for dedicated usage of resources, our servers, and so on and so forth, and for auto scaling to provide for reducing idling and other problems of not working resources. In fact, these are all the tasks faced by any serious project that claims to be successful. At the same time, compliance with these points increases environmental friendliness and reduces resource consumption. So these tasks that we really have to do according to these strange common patterns, common practices, best practices, these dry keys, never mind, practices, yes, they help us to provide more efficient code, more manageable, I would say, code. But at the same time, they provide us, not only them, but they also provide us more eco-friendly resource management of our projects. So just my personal experience, you can see that when I work my project, and for dev instance, it is Google Cloud Platform. I have several instances for test purposes, and each instance has different name for each day. And as you can see, I populated a lot of instances just for once or several times usage. At the same time, when I name this version the same name, so I have only one instance to be managed, and it really reduces a lot of disk space for my project. As you can see, it is the first point in this table, rewriting Docker images for dev and test environment. In my personal experience with the same name, just providing of such approach, of such things helped me to reduce disk space. Disk space was reduced by 95%. It was really a lot, and even saved money a lot, and so on. Also, you can see another practice is that I've provided GraphQL integration with internal cache strategy, and using GraphQL not only as something that communicates from backend to frontend and vice versa, but also like a local state management with caching data without extra request to backend. Together with CDN and Jinx, they helped me to reduce network request by 80%. Also reduced data transferred over the network by 10 times. So it was a really great enhancement, and I was really satisfied by it. Also, working with Webpack, I had previously Webpack on the project, but more work with Webpack configuration, with code splitting, thread shaking, and so on and so forth, with integrating broadly together with Nginx, and broadly was integrated very good. For some reasons, is very good for some purposes, is very powerful zipping for files. Yes, it also helped me to reduce bundle size by up to by 80%. So it was really also efficient. And about just code optimization, such practices, all of these tools, they are based on common and best practices. At the same time, just common code optimization, for example, introducing Redux normalizer, which provides hash map data structure for more quickly data retrieving for Redux storage, lazy loading for components that I have already mentioned. And I have also some custom sorting component, and I just refactored it a bit and integrated more appropriate in my way quick sort algorithm. So it is about algorithms, data structures, and so on. So it helped me to reduce the CPU load. I estimated with htop utility. So it helped me to significantly decrease CPU load. So just my real experience on my project. Of course, all this can be considered a trifle, and this economic is not worth it. The economy is not worth it. Sometimes that is true for each specific situation, but on global scale, such savings contribute to the decrease in the resource consumption. So in my experience, it was really good enhancement. In my understanding, the developer's maturity in using different practices can be called differently. Smart development or experienced engineering, or experienced development. But to my mind, one of the most appropriate name for this is eco-engineering, since efficient usage of resources and product development will always be eco-friendly. So not only for the environment, but also for our own health, financial condition, and any other goals that we want to achieve for a comfortable life, we must think about resources. With experience in every area of life, we strive to achieve the responsible kind of resource management. Responsible resource management in the engineering process by following common engineering principles and practices will always lead us to a more balanced and environmentally friendly product, as you can see. So just think about resources, it's eco-friendly, or just follow common practices, it is also eco-friendly. So regardless you follow or not this eco agenda. Because smart engineering, experienced engineering, it is equal as eco-engineering. So thank you, that is all. Yeah, I hope
thank you.
You did hear me, yeah.
And if someone have question, you can ask in chat or using your microphone. Right.
I see very good question. In one word, thanks. Vanessa. Once again, it's just I think loudly. It's not a something. It's not a guide. Just something to probably to think it over. That is all. Thank you.
Okay.
I have a question, if I may.
Sure.
Piotr Kalachin here. Sorry, I cannot turn on my camera. I have a weak internet connection. I totally support the idea of using resources in an economic way. It is good not only for our moral peace of mind, but also for economy in every way. For example, I remember developing an application that was used strictly on handheld devices and had to be available through the day. The operator was selling things from a tablet to customers. So if the tablet discharges, there's no business. They have to go somewhere, recharge the tablet. So we lose customers as a business. So I understand this perfectly. But Alexey, have you experienced a situation when the requirement for an application to be environmentally friendly was kind of motivated by environmental concerns, not business concerns? Like we know accessibility has become a requirement of law in some countries. Yes.
Thank you. Good question. Yeah, to my mind, so far, as far as I remember, no. The short answer will be no. But I think there are, sometimes I notice that more and more requirements within this context, and we have to follow some eco requirements. Probably in some time it will be more and more obvious, because you can see that the ratio in global electricity demand is increasing of IT engineering. At the same time, I would say probably the main idea is that even if we are out of this eco agent, eco context, so just following, just being, let's put it, good engineer, just put it roughly speaking, just being a good engineer, it is also healthy. Let's put it also this way. It is eco. So so that is probably, but a short answer is no. I have not faced. I haven't come across with such requirements.
Thank you.
Thank you. And we have one more question in chat from Alexander. Is there any difference between eco agenda and common sense? These eco ideas are felt for me just as clearly reasonable.
Probably everything is connected. So we can say that eco agenda is something separate from common sense, or even comparing common sense with good engineering is have the same relationships. So probably they have the same base, I would say. Common sense, eco agenda, probably. I just my thoughts. Good engineering, or probably well resource management. Even take care of ourselves, of our private lives, and so on and so forth. So yes, I just shows that how they are connected, probably best practices or common practices, they're based on common sense, and when we follow these practices, we can see that it is eco-friendly. So we can find a lot of such relationships all over this context. If I understood this question in the right way, so that would be my answer. Thank you.
Yeah. Okay, thank you. Anyone else? Okay, so Alexey, thank you for your speech. It was very interesting, and we will go on. So Vladislav, your speech is next about Next.js. So you can start. Please share your screen.
Okay, yeah, thank you. But yeah, Vladislav's here. Hey, everybody. First things first, Alexey, that was a great talk. Thanks a lot for that. And you know, this is not a kind of topic you think a lot in your day-to-day life as an engineer, but when you hear about it, you realize that you're not only in making a project better by incorporating best practices, but also help to save the environment from the human, you know, stuff. So that's great to know. And before we start, I'd like to share my thoughts about why have I exactly decided to talk to you about my topic today. And so I've been a UI developer for quite a while, and I was mainly working with React kind of UI development. And lately, I've started facing certain limitations React has. Of course, they could be, let's say, fixed. We can have some workarounds to go through them. But for example, it appeared that making a React application search engine friendly or optimized is a really hard thing to do. And so, for example, a server-side rendering could be incorporated in such a case. But I've learned it the hard way that incorporating server-side rendering for React application, the custom one, could be kind of complicated. Yeah, React also, let's say, is a tool that is used specifically to only manage UI, and that is really cool. I find that that fact really awesome about the React.js library, because yeah, the only thing we could do with that is UI, and React is super cool at this. But sometimes I feel like I need some more features with the tool I'm working with, so I have more freedom with not to have tons of boilerplate code and stuff. And so I found my way into the new era of, let's say, of development with Next.js. And so that is the topic of our today's Tech Talk. And so for that, I'm going to share my screen. Hope you can see it. So as you can see, yeah, I'm talking of it as an evolution of React development. Of course, that sounds a little bit, let's say, as a big word, but that's more of a clickbait, of course, because I don't think Next.js is going to replace React in any case. But for some certain use cases, Next.js could be extremely useful, and we'll talk about that today. So I guess we can start. And the first thing that I would like to discuss to you before we actually drop to the technical part, let's say, is the, let's say, so-called requirements I'd like you to possess in order to, let's say, enjoy this topic. And yeah, the answer in here is that this Tech Talk is has no strict technical background, so you don't need to be an experienced React.js or even UI developer to understand what we're going to talk about, because that would be more of a high-level overview of the tool. So this library, this framework is already popular and it's still gaining popularity. And the reason I would like to talk to you about it today is because I want more projects to be incorporated with this framework. And so whenever a developer, a project manager will know about this technology, they could think of onboarding it on the project, and so more projects could be incorporated with the technology. That is my dream, let's say. And yeah, so I would like simply to share my thoughts about and my experience in modern, let's say, React development. So let's jump right in. And to begin with, let's discuss our plan for today. So firstly, we're going to go through some introduction. I'll describe what is Next.js, how it appeared, who created it, why we need that. Then we're going to discuss such a topic that I've called web design patterns. You don't need to think of them as like, you know, the design patterns, the gang of foreign stuff. That would be more connected to content sharing, content rendering, and content pre-rendering strategies in full stack web development. After that, we're going to talk about some features Next.js ships to us out of the box, because Next.js is a feature-oriented tool, and you'll see that in a while. After that, we're gonna switch to the topic about relationships. So who uses Next.js, who likes Next.js, and maybe we'll have some examples of big production companies that use Next.js right now. After that, we'll move to the community of Next.js. And I would say this is my favorite part of this technology, because yeah, as I have already said, Next.js is a pretty popular framework already, and it has already some, let's say, really friendly and cool community. And we'll discuss where you could see it and where you can incorporate some experience. And yeah, so we'll talk about it in a while. After that, we'll see quickly the deployment options, because yeah, any kind of technology might be cool, but in case you can't deploy it in an easy way, who needs that? So we'll talk about that. And we'll move to the wrapping up. After that, I guess we might have some time for your kind of questions, so I would be able to probably answer them. So let's start. And firstly, let's think, what is Next.js? What is it? So according to the creators of Next.js, so the creators of Next.js are the company named Vercel. And so here you can see the description of Next by its creators on their official website, nextjs.org. And so what do we see here? Next.js is the production React framework. Okay, that's cool. And let's now take a closer look at the description. Let's not read it out loud, but let's try to highlight some words, okay? So Next.js gives you best developer experience. Okay, so this is really strange for a framework, you know, for any kind of a framework. Frameworks and libraries in, let's say, modern programming world are aimed to solve specific problems. And on the first line here, we don't have a specific problem. We have an enhancement of developer experience. So this is extremely interesting fact that actually this framework aims to give the best developer experience possible. I find this pretty awesome. So what do we have next? Okay, everything you need for production. So this framework is production safe and tested. Yeah, it has a rich history. It is not, let's say, very new. It has been released around 5 years ago. What do you see next? Static and server rendering. We'll talk about that in a while. TypeScript support can come in handy sometimes. Smart building, blah, blah, blah. And finally, no config needed. So configuring of tools, libraries, and frameworks could be really hard nowadays because yeah, you can use multiple of them at once, and dealing with each particular configuration could be difficult. And so Next.js claims that you don't need to configure anything, and we'll see that if that's true a bit later. So now let's talk a little bit in details what kind of features incorporates in Next.js and what it is. So on your right, you can see fancy Next.js logo. I would say I like it. And so Next.js is a framework that is based on React. So in case you already know React, the learning curve of Next.js would be extremely, let's say, flat. It has plenty of features out of the box, and we'll talk about what kind of features that are worth mentioning it ships. It has really, really awesome quick start notes and documentations. And yeah, in case you're new to a technology, the best place to learn it is, of course, official docs or quick start notes. And so learning Next by its official docs feels more like a game, not like reading a documentation, because it is extremely cool. So I recommend checking it out. Next.js was developed by Vercel, and it is worth mentioning because Vercel is a kind of company that cares about its child being Next.js, and we'll see how. Also, yeah, it supports SSG, SSR, and CSR, and we'll discuss what those fancy abbreviations are in just a while. It requires little or no configuration, and of course, we'll have more details on that later. And it is aimed to improve the developer experience, which is really cool. And we'll also see what Next.js exactly does to improve the developer experience. So in the first topic, let's say introductional one, just so I'm sure we're on the same page, I would like to discuss with you so-called web design patterns. And under web design, I mean content rendering and pre-rendering strategies. So web design patterns in terms of content sharing and rendering. So what do we have now in terms of those strategies? So we have something that's called CSR, that stands for client-side rendering. And you could hear about it as always, also a single page application. So all of the rendering happens on the client side. And a good example of it is, of course, React.js, because this library is something that our framework of today's discussion is based on. But a good example of client-side rendering library or framework could be also Angular, Vue, Svetel. So some of them are many of today's, let's say, popular UI solutions are incorporated with such a client rendering strategy. Also, we have something that is called SSG, that stands for static site generation. And the conventional example of it would be Gatsby.js. That is also a framework based on React.js that is well known for static site generation. It was extremely popular some years ago. Now, I would say it is going down a bit in popularity, but it still has, let's say, it's part of the audience in the UI web programming world. And the last but not least strategy we'll discuss today would be SSR. That stands for server-side rendering. And a good example of it would be Next.js. But with Next.js, it gets a little bit tricky. And we'll know why it is tricky with Next.js and SSR in a moment. So now let's discuss each of those strategies one by one, so we know what they are and we know their pros and cons. And we'll start with client-side rendering. So now we'll see how the communication between client and server happens in terms of client-side rendering. So in here, in our example, we'll have two entities: the client, that could be a browser that a user uses, and a server, some machine in the cloud or anywhere else, and they will be communicating. And here we can see the timelines. On those timelines, we will have actions that happen. And so the first thing in our, let's say, pattern that happens between client and server would be a request of a web page to a server by the user from the browser. So just typing a domain name and hitting enter, that would be an HTTP GET request to the server. Then the server replies with an asset, and in our case, that would be HTML document, and so server sends it to the client. Also, this HTML document is of course incorporated with some links to static assets, JS files, CSS files, and stuff. Then it takes some time for a browser to download HTML, the HTML page, to load into the DOM, and also to download JS, CSS, and other assets files. And so only after that, the browser executes JS, the downloaded JS, and the React scripts that were sent within HTML. And only after that, the page gets populated with the content. And we'll see why is that. And so this kind of approach, this kind of strategy could be also referred to as SPA, or single page application, and that is the default behavior for React applications. It could be also default behavior for other UI libraries, but yeah, now we're talking about React. And now let's discuss it a little bit in details. What let's say pros it has, what cons it has, and stuff. So just the fact, in client-side rendering, a client receives an empty HTML page with the first GET request. Also, the JS populates the page with content after the HTML was rendered to the DOM and the React scripts were, let's say, run. The routing, all of the routing is happening on the client side. So you can't just access some specific route, and the server would not change its answer. So the routing would only happen in the browser and would be run by the JavaScript on the client. It could be referred to as blazingly fast because before such kind of single page applications were invented, if to compare them to, let's say, the conventional applications of server-side rendered ones, such an approach is extremely fast because modern clients, modern browsers are incorporated with pretty lot of enhancements that help to render JavaScript in it very fast. And so React is also pretty optimized library that works fastly. But it comes at a price because such single page applications, they are not search engine optimization friendly. And why is that? So at your right of your screen, you can see a physical representation of an HTML document that is being sent from a single page application serving server. And as you can see here, we have some common HTML things like tags and stuff. And the thing of our interest here is the body tag. Here you can see the div with ID root, and it is empty. And so that is what a client of a single page application gets when it receives the application code from the server. And it takes some time for a browser to execute React code with JavaScript, and only then this empty div with ID root gets populated with the content. Of course, most of the times this kind of delay is not seen to the user because React is really fast, but it makes our application not search optimization friendly. And yeah, that leads to some crawling issues. Crawlers are special robots by search engines like Google, for example, that are crawling through the web and indexing on all the web pages. And so for such applications, the crawler user agent is usually blocked. Of course, yeah, we can unblock it, but the only thing it could see is an empty page without any kind of content. That is what happens to such applications by default. Also, not every page has its own URL. It kind of depends on the developer, because yeah, in React and in any kind of UI library with single page approach, we can handle routing without changing the URL. Because the client-side JavaScript would change the content. Of course, this is not a best practice, but that could happen for some parts of application. And dynamic roads are invisible for the crawlers, because the only physical page that we will have on the internet and indexed by the crawlers would be this empty HTML that we just saw. And that is a summary on what is client-side rendering. Let's move on. So now we're gonna discuss the same thing, but for server-side rendering, let's say, strategy. And here we'll have same two entities, the client and the server. So, and they would also have the timelines and the actions. And the thing that happens first is, of course, HTTP GET request from the client. Nothing changes here. But then the server does something interesting. It takes some time and some processing power to generate HTML from your React application. And only then it sends a reply to the client with HTML and links to assets like CSS and JS. And the good thing about this HTML that it is not empty. It has been already populated with content. And so all the browser needs to do is to render HTML into the DOM and show it to the user. And the user would be already be able to see the content of the page. Even if JavaScript is disabled in the browser, some content would already be loaded. And the only thing the client would need to ship a fully fledged application is to run the JavaScript, and the page would become interactive. And now let's talk a little bit in details about this strategy so we understand how it works. So the content of a web page with such an approach is being evaluated at runtime. And for some perspective, that could be really good, because for different people, for different users entering our website, we can show slightly different content. It could be personalized content, for example. Also, the browser has just to render the page into the DOM, the HTML, and already show some content. And so even if JavaScript is, for security reasons, for example, is disabled, the user will see some content. That's cool. When the pre-rendered page reaches the browser, JavaScript code is run to make the page interactive. That's what we just have discussed. And this whole process is being made to make the load speed faster. And here the important thing that I would like you to understand is that it will still take a bit more time than client-side rendering, but the load speed means the time when the browser has already got a response from the server with HTML, and only now it is a bit faster than the client-side approach. Also, this kind of a rendering strategy is search engine optimization friendly and crawler friendly, of course, which is good. But yeah, we have so many, let's say, good things about it, but it comes at a price, surely. And we can have potentially easy server overload with such a strategy, because we need to render some content with our server for every kind of request. Of course, some of the requests could be cached and stuff, but that is the default behavior. Also, the client has to wait for the server response, because it takes some time for the server to render the HTML and to populate it with content. And the dynamic routing could be slower compared to single page applications, but that is something we could not fix, because yeah, single page applications in the client are always more, let's say, efficient in terms of loading speed. And finally, we're moving to the last rendering strategy I would like to talk to you today, and that is static site generation. So here we would have same two entities, client and server, but we will have one more, and we'll call it build tools. And let's see how do they interact to incorporate such a strategy. So the first thing that happens here is not actually a GET request to the server. The first thing that happens is a generation of static files by build system. So that is something that is being run on your server when you're deploying an application. And a build system, that could be Webpack or any kind of other bundler or a specific tool. If you're using a framework, they analyze your React code, run it, and generate static HTML files from it. So now we have HTML files for every kind of route you have already populated with content. What happens next is a deployment of this web application to your server. All of that is being happened at a build time. So it doesn't affect in any kind of way the user. Maybe only it could take some maintenance on your server, some downtime, but yeah, we don't care a lot about it right now. And then in terms of the strategy, the next thing that happens is actually a GET request from the client to the server, just like we had before. The good thing here is that a server will instantly replies with assets because all of them have been already generated during the build time, and of course the HTML files. The client should receive them via the HTML respond and downloads HTML, renders it to the DOM, then downloads JS, CSS, and stuff. The really good thing about it is that all of it is already populated with content, and we didn't need to wait for the server to render it because it was already made during the build time. And all of such behavior happens during the runtime of the application. So that is when the user can see the difference. And let's talk also about it in details. So the content during static site generation is being evaluated at build time. What does it mean? So it means that we might have a less, let's say, a server that is weaker for running the application because the rendering of the content, which is a heavy operation, could be done during the build time on some other server. So we can save some resources, I would say. Also, all of the whole application for the first kind of GET request acts as static content, as if you have implemented your application the old ways, just with vanilla HTML, CSS, and JavaScript without any kind of single page application framework or something. Also, the good thing about this, of course, just like server side, it is search engine optimization friendly and friendly to all of those kind of things. But it also comes at a certain price, of course. Dynamic content management is a hard thing to do because you need to preserve states between different pages that don't share it by default. And dynamic routing could be SPA only, so single page application. That could be at the same time a good thing and a bad thing, but we will talk in details about this kind of part a bit later. And now let's remember why have I called Next.js to be tricky about server-side rendering. And actually, let's try to put Next.js between those rendering strategies. So to which kind of a rendering strategy does Next.js correspond? And here, an interesting and truly powerful answer would be Next.js could incorporate any of those on demand. So Next could be client-side rendering, client-side rendered, could be server-side rendered, and could be statically generated. And for that, we have different kind of tools in Next. For example, for client side, we have dynamic in Next. For server side, we have such a function with a fancy name. And for static site generation, we also have such a function. It is kind of easy to use them in the code. You just need to incorporate that to the corresponding place in your JS pages, components. So, and Next will incorporate own rendering strategy for each page on demand. So you can choose strategies as you want to. So, and now let's summarize all of it, all of these strategies on the topic of Next. So Next, of course, lets you choose which kind of rendering strategy to use for each page. And so you can create a hybrid application that could incorporate client-side, server-side, and statically generated assets. It is recommended, of course, to use static generation over server-side rendering for performance reasons, because server-side rendering would trigger for each request. But there still could be use cases for server-side rendering because it could be more secure. It could have more personalized content for the user. And yeah, so it has its own use cases, but if you don't know what exactly to use, it is recommended to use static site generation. And also, of course, you can use the client side just with all of those rendering strategies. In some parts of a page, even if it was statically generated or server-side shipped, you can still load some, let's say, exact components with the client rendering strategy. And here, I just want you to understand what kind of freedom in terms of content serving we have with that kind of framework. And now I guess we can finally talk about what features does Next.js ship to us to be developer-oriented, developer experience-oriented framework. And so at your right of your screen, you can see a screenshot of the official docs of Next.js with the description of the features. We won't like go through all of them. We will only name, let's say, worth mentioning on my personal opinion. But as you can see, there is quite a lot, and that is not the full list, of course. And so, yeah, Next.js is a feature-oriented framework, and it is aimed to enhance developer experience. So let's jump right in and see how it copes with that. So the first feature I would like to notice, and I would say it amazes me a lot and helps me in my personal kind of projects and development experience, is enhanced routing. What do I mean by that? Next.js incorporated so-called page-based routing or file system routing. In case some of you are familiar with the Ruby programming language, it has a framework that is called Ruby on Rails. And so this is a conventional example of what file system routing is. So yeah, of course, if you're not acquainted with that, you don't need it to understand what we'll talk about, and we'll see a little example just right now. Also, Next has a built-in router, so you don't need to install React Router or to think about your custom solution for that, because all of it is already incorporated by Next and done for you. I really like it because I kind of hate dealing with routers in client-side applications. Sometimes could be tricky. Also, Next.js ships with so-called API roads feature, and you can write your backend code inside of your frontend application to make it full stack. And you can do it just by creating a special file in a specific folder. And so already you have API roads that reply using the Node.js. At your left, at the bottom of the screen, you can see let's say the conventional way of how we deal with routing on the client side. So you can see a screenshot from an app.js file of a really scaled, let's say, React application. So what we can see here, we can see lots of code that is barely visible, I guess. And that is mainly because we have lots of different routes, and all of them should be put in that exact file. And that makes it really hard to read, to understand what happens here and stuff. And it also makes this app.js file kind of big. Of course, yeah, it could be put in some other file, but that is how conventionally developers deal with such kind of things. But what does Next.js provide us with this file system kind of routing? With Next.js, we only need to create a structure of folders, and it will create routes for those exact folders and files. So to create a route, for example, /posts, you only need to create posts.js file inside of the pages folder in your repository, in your project, and that would be it. So you won't need to think about the components and stuff. And it sounds like it is not, let's say, extendable, and you cannot have dynamic routes with like IDs and stuff, but you can have them, and that is pretty easy. The next feature I would like to discuss with you is the fact that the builds in Next.js are extremely fast. Of course, builds of single-page applications with React could be also fast, but comparing to some other, let's say, full-stack frameworks and stuff, Next.js is extremely powerful and fast. And let's see why. Of course, Next.js is incorporated with HMR, hot module replacement, and you can instantly see the changes. And the cool thing about the latest version of Next, it was released, let's say, half a year ago, Next.js 12. They changed the compiler and have rewritten it to the Rust programming language. And let's see what have they gained about it. So they built improved in time from 3 to 5 times. They've got some speed improvements for large code bases, whatever that means. They improved observability into the performance. The underlying Webpack configuration that is being used by Next.js has been also improved. And the Rust compiler is much faster for minification as the conventional way of how we minify files in React programming with Terser plugin. And yeah, it is at least 7 times faster. And about more, let's say, big numbers, Rust compilation is 17 times faster than Babel. So to transpile your React and JSX code to and ship it to, let's say, the production version, you can do it faster with Next. Yeah, and here you can see the presentational part of those data from Next.js developers. One more feature that is worth mentioning is image and font optimization out of the box. You don't really need to worry about it a lot. So in Next, we have a already built in and shipped component that is called image. You can just import it from the Next package and use it. And some of the built-in optimization include the following things. So images that are being served with such an approach are already with improved performance. So if you ship multiple image sizes to this component, it would automatically detect the best suiting image for the current device format, and it will show the correct ratio of the image to the user. Also, it incorporates some visual stability that is being managed automatically. So it prevents content and layout shifts after the image is being loaded. Also, it incorporates the whole application, the whole project with faster page loads, because lazy loading is enabled by default to images, and you don't even need to configure it. You just need to use the image component imported from Next, and it could also blur the image on load before the actual image is being loaded. Also, we have some asset flexibility. We can resize images on demand during the runtime, and we can use images that are being searched from remote image servers that ships image. So you can not store them on your, let's say, dedicated servers, which is extremely cool. And yeah, the one more feature that is worth mentioning is that Next.js has built-in ESLint and TypeScript support, which could be extremely handy. So the only thing you need to enable TypeScript in a Next.js project is creating it with a flag. So Next has just the same thing React has, create React app, but create Next app. And you can just create it with TS flag with npx or with yarn with TypeScript flag, and now the application would use TypeScript. But you could ask, what if I have an existing Next project? How could I enable TypeScript here? And so, yeah, it is even more easy. You just need to create a file in the root folder of your project that is called tsconfig.json. And on the next project start or build, the Next framework will automatically see it and incorporate it with default instructions, this kind of file. You don't even need to specify the configuration. And also regarding ESLint, there are several plugins that help you follow the best practices shipped by Next developer community. And all of those plugins are also enabled by default. So you're ensuring the best code quality with zero configuration. I guess that is extremely cool. Yeah, and as I have already said, Next.js is a feature-oriented kind of framework, and it has much more features that I have just mentioned. So other features that are worth mentioning could be internationalization that is built in, analytics, hybrid SSG and SSR, incremental static regeneration, API roads, built-in CSS support with CSS modules, code splitting and bundling, support for environment variables, custom head tags for each page for like meta tags or style sheets or SEO tags or anything. and deployment of the Next.js application anywhere where Node is supported. Of course, that is also not a full list of features that Next.js provides, and there are like more features, but we don't have much time to discuss all of them. So I hope you will get acquainted with them someday. So, and now let's talk about the features Next.js does not provide. Of course, yeah, it is feature oriented, but they could not possibly incorporate all kind of features a web developer could use in a framework, because yeah, in that case, it would be huge. There are, of course, features that Next.js don't provide out of the box, and you need to think of those features yourself. The list could be also bigger than I will show, but those are most classic problems Next.js doesn't have. So the authentication is something that is not completely managed by Next.js, and you need to think of authentication, authorization, and security of application yourself. And for example, there is a handy package that was created, I believe, by Next developers that is called Next.auth that handles such problems. So you can use that, but also any kind of other solution you might come up with. Also, Next.js doesn't ship E2E tests and testing by default. Yeah, and you'll ask, what about unit tests? And so it configures the jest to be enabled by default without any kind of configuration. But yeah, E2E testing is something that you need to think yourself again. And for that, you can use some classy solutions like Playwright or Cypress. And the last thing that I would like to mention about the features that Next.js does not provide would be the state management. Of course, for many kind of applications, you need to question a lot if you need a state manager. But in case you have the specific use case and you truly need a state manager for statically generated web application, yeah, you can use any kind of solution because it will be compatible with Next.js, because afterwards it only has its magic during the build time, and then during the runtime you have the old same React application. So we can use Redux, Recoil, Mobex, Relay, React Query, any kind of thing for state management or dealing with your backend. And that was all the features I personally would like to mention. And now let's see the relationship between Next.js and developers that are using Next, the relationship between Next and big companies you might know. And so I will show some statistics. This statistic would be mainly based on the state of JS of 2021. You can check it out because that is an extremely interesting survey that took place for quite a while. So there are information about even previous years. And yeah, so the most of the statistics was took from the stateofjs.org. So 91 of 100 developers that are using Next are happy with the framework. So they like the way the Next cares about their experience. 45 out of 100 projects use Next at the moment. So I guess Next is still kind of rare thing to have in big production scale applications, because these statistics, it is only about projects that have been started in 2021, of course. And let's say older applications do not migrate to Next extremely, they do not do that usually. And 70 of 100 UI engineers are being interested in Next.js. And that is a really good thing, because the community of the developers is growing extremely fast, and we'll talk about it just in a moment. And now let's see what kind of companies you might know are using Next.js already. And so here you can see some examples of big companies you could have heard about. Of course, that doesn't mean they are using Next for their main products, but it means that they are using Next for something in their product life. That might not be the main product, but yeah, it could be anything virtually. And in case you're interested more in terms of who and how uses Next.js, you can visit their official page, and they have a dedicated listing, the showcase of who and how incorporates Next.js in their programming world. So now we're going to my favorite topic, the community, and now I would like to show you the best things about Next.js community you can, let's say, approach in order to learn the framework, in order to have new connections with some other developers that are interested in the framework, and to learn the framework itself, because the community helps a lot with learning. So we have such thing that is called Next.js conference, and you can access and see when the next Next.js conference would take place. And so they do them like twice a year. That was a good old tradition for some time. And I would say that those conferences are extremely useful, and guys usually incorporate the conference for a release of a new version of Next.js, so you can see the latest news about the framework. And the thing I would like to encourage you to do with that is to watch a recap of the last Next.js conference that was dedicated to the Next.js 12 release, because it was an extremely major release that put this framework a lot more forward in terms of yeah, so it advanced a lot. Also, the official docs of Next.js that are also could be seen at the nextjs.org website are extremely useful. They are extremely useful to go through and to learn the framework with the official docs, so you can check them out. Also on their website, we have a topic that is dedicated to examples. So Next.js is a pretty, let's say, complicated tool, and in case some feature is not configured by default, you might think, how do I configure it if I need it? For example, I would like to incorporate my application with styled components. And so Next.js has over 100 repositories that are being examples of how to start properly the Next.js project with a given technology. That could be GraphQL, styled components, authentication with Next.auth, and many, many more examples. So that would be a good start if you want to enable some feature or some library or some other framework to be responsible for some other things, and you don't know where to and how to start. So that would be a good quick start. Also, they are holding, let's say, a blog with the latest news in the Next.js field. And so, yeah, it is extremely consistent, and I would say straight to the point. They don't watery their articles a lot, and I personally gained lots of useful information from it. And they also have big and vast online communities in the social networks. And for example, they have a pretty scaled Discord server. And I have personally used it to ask my personal question about Next.js, and other, let's say, just simple developers, not the developers of Next.js, who are inside the community, were able to help me. So the community is extremely friendly and aimed to help the newcomers. And yeah, finally, we've got to the point of how exactly could we deploy Next.js application. And here I would say that it could be kind of easy because you have the flexibility to do it. So the most conventional way, and the thing I would like to encourage you to try first, is the official Next.js deployment option with Vercel, so the company that created the framework. You can also use the deployment with AWS or any kind of other cloud solution. You can use a DigitalOcean if you like it, because yeah, they have pretty much powerful servers and stuff to ship. And in case none of those solutions not working for you, you can use Docker and deploy it whenever you want, even on your personal machine. And so the exact reason why I would like you to first try the managed solution by Vercel is because they have a pretty much generous free tier that makes my personal life as a developer much more easy. So you can deploy from CLI or personal Git integration, so you don't need to upload code directly to Vercel. They have built-in CI/CD, just like I don't know, Circle CI or Travis, and it works really cool without any kind of configuration. You just have it out of the box once you deploy your application here. I would say it is extremely useful. Also, they ship automatic HTTPS and SSL certificate to your domain, even custom domain. Of course, that is not commodity positive SSL certificate. That is Let's Encrypt, I guess. But yeah, it is already better than nothing. And you have a preview for every Git push. Even if you are not building your main branch, let's say, Next.js will see automatically pushes to some other branches and create a test preview build for this branch you can access and test before you move it to production. Yeah, and also Next.js applications could be hosted anywhere where Node.js is supported. That could be AWS EC2 incorporated by or created by Elastic Beanstalk. But the most, let's say, conventional solution, if you're going with AWS hosting option, would be AWS Amplify, because they have already configured Next.js deployment option. It could be DigitalOcean Droplet or a custom Docker image, and you can then ship it on any kind of virtual machine. Yeah, and finally, we've moved to the point where I have, let's say, finished my thoughts and shared my experience I wish to share with you. And so I'm extremely glad you've been with me for this time. And yeah, I guess now you understand what Next.js is, and you might think of using that kind of technology on your next project, or incorporate it into the existing one. And so now we can have some time for some Q&A session. So in case you have any kind of question, I could remind that we have a chat at the bottom of your Zoom window. And yeah, you can speak out loud or write your question to the chat. Thanks a lot.
Yeah, Vlad, you do my work.
Sorry.
Yeah, if someone have questions, you can ask now. We have 2 questions. Can you read questions?
Yeah, I will do. Thanks. So the first question from Petr Kalchin. Hi, Petr. Is there an Angular counterpart of Next.js? So that is an extremely good question, because yeah, of course, not every UI developer that uses single page application UI solution uses React, because yeah, React might be one of the most popular solutions at the moment, but Angular is a pretty, let's say, a serious rival of React. And I would say that I reckon there was such a solution, at least maybe not so feature incorporated, but it was shipping. It was a plugin, I guess, for an Angular. I can't remember its name for the moment, and it was shipping the server-side rendering and static site generation for Angular out of the box. So I guess after a minute of Googling, you could find it. So there certainly should be a similar tool, maybe not so fancy, but maybe even just as fancy. So hope that answers your question. Okay, I'll move to the next one.
Yes, from Vanessa.
Vanessa, hello. For what kind of projects I might use next? So that is also a good question, because I haven't mentioned it in my presentation. And so, of course, for each kind of tool, before you use it, you need to think if you really need it. Because yeah, I think throughout my career and experience that many people use really heavy lifting tools for the tasks that don't need them. And so with that, you just increase the complexity of your project, the complexity of the dependencies, and you, yeah, and the potential users could feel that in terms of loading speeds and stuff, and it is harder to maintain the project. And so Next.js is a pretty heavy lifting tool, I would say. And so the best use case scenario for a Next.js application would be, on my point of view, if your application is extremely search engine optimization crucial. What do I mean by that? So your audience, the main cluster of users potential that will visit your website, should seek for that on the web. So in case Google or any kind of other search engine solution is the main, let's say, target of your, the main way to lead your audience to your website, in that case, Next.js would be extremely powerful, because yeah, search engine optimization is extremely easy when you're talking about Next. And also, yeah, in case your application is not search engine optimization crucial, you might not need Next.js, of course, but you still could use it because the features that are being there to improve developer experience would not disappear. They would be still here. And so in case you need to bootstrap a project quickly, or not to care a lot about some features like image optimization or server-side rendering, or I don't know, anything else virtually, that could help. So thanks for the question. And okay, what about microservices? Does Next.js support and wait to deploy its parts separately? So that is also a good question. I would say that for my kind of experience, I haven't yet faced such a deployment requirement to have Next.js application deployed on a microservices architecture. But what I could say for the moment, yeah, I don't know if the exact app could be exact Next.js server could be deployed on the microservices architecture, but you still can deploy any other parts of your application in a microservice, let's say, way. That could be the server parts. You cannot use the full stack solution of Next.js implicitly. Maybe some authentication, authorization things could also be incorporated by microservices. But yeah, I guess for the moment, I can't give a more descriptive, let's say, answer. But thanks for the question. Also, I consider Valentin proposes Angular Universal as a Angular solution for static site generation and server side rendering. And yeah, I reckon something like that. So thanks, Valentin. Yeah, I guess that is the thing I was talking about. Okay, cool. And I see one more question. I'm planning to combine static site generation with a single page application. Can you give an example of an application like this you have developed? So I would say that to this time, you know, the main purpose of this tech talk was to raise the familiarity of developers and other tech people with Next.js, because I really want to work on a production Next.js project and I haven't got an opportunity to do so. But I developed my personal side kind of projects and pet projects with Next.js because yeah, it helps me a lot. And so I did have let's say commercial experience with Next, but for the moment I wish it was a bit more of a commercial experience in that kind of field. And so if to talk about why would you need to incorporate different content rendering and pre-rendering strategies in a single application, so we can think of it for a following, let's say, pattern. So if you are developing, let's say we are developing an e-commerce application and we're selling some products. And so for each kind of product and for each kind of a product page, we can use static site generation solution. And all of the product pages and product listings would be generated during the build time and served statically to our deployment server. And so Google and other search engines could index it and show it to the users. Then we can implement client-side rendering solution for some heavy lifting parts of our application we don't want to use on the server. For example, some filtering or searching through our products. Because yeah, we don't really want our server, maybe in some cases, to handle some front-end filtering or reordering of components. So that could be done on the client implicitly. Or we could also incorporate client-side rendering for personalized solutions. So for example, we can have statically generated page, and we can render on it during the runtime using client-side approach, some personalized hints or enhancements, or yeah, hints what to buy next on our app. And yeah, lastly, if we would have some really security crucial parts of our application in this e-commerce that could be, for example, something connected with payments or checkout. We can use server-side rendering for that, because in that case we can ensure that nothing will interrupt the work of the client and of the server, and we can dictate our own rules of how do we render things and what do we do on that kind of page. So I really hope that answers your question. Thanks. And for the moment, I don't see new questions. So
yeah, maybe someone want to ask with microphone. I see that Piotr is unmuted.
No, just to say thank you. I'm muting again.
We have one more in chat.
Yeah, we do. Next, using Rust-based SWC compiler, would Next move forward with WebAssembly server and client-sided Rust then? So that is also a good question. And moving to a Rust SWC compiler was already a big step for Next.js, because yeah, conventionally and previously before Next.js 12 that was released a bit maybe later than a bit earlier than half a year ago, they used the conventional way of how to deal with compilation, the Webpack. And so now, as they have enhanced the project and the build tools and stuff, they already gained some enhancements. And so the key item here is, of course, we have WebAssembly now, and it is more efficient in terms of client-side things and stuff. But Next.js is already a pretty big tool, and making some business crucial, some feature crucial changes that would require refactoring of the whole tool is extremely hard for them now. So I guess that is not their, let's say, priority for the nearest future. And I believe we will stay with good old JavaScript on the client side and good new Rust compiler on the during the build time. But yeah, that is also a clever question. Thank you, Andrei.
Okay, thank you, Vlad. I think that is all, because we have at least time. Okay, and thank you our speakers, and thanks to everyone who joined us at our meetup today. The recording of the conference will soon be posted on our YouTube for Grid Dynamics, so you can rewatch it or send to your friends. Thank you again, and have a good evening. Bye-bye.
Thanks. See ya.
Everyone. Bye-bye.
Thank you, speakers, moderators.